Welcome to Efiwe, excellence without stress.
Welcome guys to Efiwe, excellence without stress. And today we are going to be looking into something. We will be able to identify the formation of a new substances by just using the evidence of possible chemical changes, such as production of gases. So in a situation where you decided to start burning wood or paper, and as you are burning that wood, you begin to perceive something choking. The implication is that there is a new substance likely formed. We could also find out how new substances are formed by considering change in temperature, production of a precipitate, or any color change. Join me on this journey as we understand the chemical and physical changes of matter. A physical change is simply a change of matter from one form to another that affects one or more of the physical properties of a substance without changing the identity of that particular compound. So you notice that when a process is said to be a physical change, the particles of that matter will retain their identity. If it has a particular property, the fact that it is now mixed with others will not change it. A very good example is when you are preparing soup. You will notice that the meat is still meat inside the soup, even though it is combined with other things. The highest thing that could happen in the case of meat is that it would now be more flavored, but the protein it contains will still be there, and so on and so forth. Moving ahead, we could consider physical changes when we talk about changes in the state of matter, and such changes include freezing. Freezing is a conversion from your liquid to your solids. When you now melt, it is now from your solids to your liquids. Dissolution is when you put a substance inside a solvent. You could also have sublimation, which is the conversion of a solid to a gaseous state without an intermediate liquid state. You also have vaporization, which is the conversion of your liquids to your gases, and condensation, which is your conversion of your gases to your liquids. Finally, we also have deposition. Deposition is a change directly from gaseous state to solid state without an intermediate liquid state. You also have change in texture, change in appearance, or change in size, like when you are cutting yam and you are about to cook. That is a physical change because it simply has to do with change in size. Moving ahead, the examples of physical change include stretching a rubber band, dissolving sugar in water, melting butter, crushing an aluminum can. So you will notice that these things will retain their identity. The sugar that you put into your mouth is still going to have that same sweet taste as when you put it inside water, which implies that dissolving sugar in water is simply a physical change. Let's now consider chemical change. A chemical change occurs when one or more substances change into an entirely new substance with different properties. So the emphasis in chemical change is that a new substance is formed. Chemical changes are not exactly the same as chemical properties. Yes, please note that. A change or chemical changes are simply processes by which substances change into new substances. A very good example is burning. Because when a substance is burning, you will notice that if, for instance, we are considering the combustion of your hydrocarbons, the combustion of your hydrocarbons would lead to the formation of carbon dioxide and water after complete combustion occurs. So you notice it used to be ethane, but after burning it, it turns into carbon dioxide and water. If you have kerosene in your kerosene lamp, it used to be kerosene, but then as it burns off, it forms your soot because of the insufficient amount of oxygen, and then you have that. Moving ahead, chemical properties are now things that describe which change can or cannot happen to a substance. So when you are considering the chemical properties, it is simply describing the changes that you can say can happen or cannot happen to a substance, just basically the properties of that element. Examples of chemical changes include burning wood into ashes, liquid cake batter turns into a solid and a spongy cake, fireworks under a chemical reaction and creates colored light and sound, iron oxidizing, which is the rusting process, and digesting food. The next thing we are going to talk about are the signs of chemical change. The first sign is the production of a gas. Anytime you notice that you combine two things and you notice fizzing, bubbling, or foaming as a sign that a gas has been produced, it is usually a chemical change occurring. So some of you that take your things like your tom-tom and put it inside lacasera and you start noticing a particular reaction, or maybe any of your Mentos and put it inside Coke, you will notice that it will now start producing a lot of gases. That is indicating a chemical change. When there is production of thermal energy, it also indicates a chemical change. If you have a change in color, for instance, if you happen to introduce your oxidizing purple potassium permanganate into a sugar solution, or maybe you introduce it into something like an ethene or maybe you introduce it into ethene, you'll find out that the ethene would actually reduce it and change the color from purple to colorless. The next one is formation of precipitates, just as you have in situations where you combine two liquid solutions, and in those solutions you have some salts. When those salts combine together, if you have two soluble salts, in most cases you are going to have the formation of an insoluble salt, which is the precipitate. The other sign of your chemical change is a change in odor. So when you start perceiving something that you are not supposed to be perceiving, the implication is that there is definitely a chemical change occurring. So when you smell apple pie or spoiled milk, it is evidence that a change has occurred. If you keep milk, normally milk doesn't have a very bad smell, but when you leave it after a while and you begin to perceive funny smells, a chemical process has occurred. You also have production of light or sound. So let's compare your physical and chemical changes. The chemical changes result in new substances, while the physical changes do not. Many physical changes are easily reversed, while most chemical changes are not. Chemical change indicators include changing color, odor, heat production, fizzing, foaming, giving off of light and sound, and creation of precipitate. While in the physical change, you may or may not see these things. With this, we have come to the end of our study. Thank you very much for studying with us. Do solve the questions in the Efiwe app.
Welcome to Efiwe, excellence without stress.
Welcome guys to Efiwe, excellence without stress. And I remain your favorite chemistry tutor, Godson. Now, have you ever imagined a situation where your mom sent you on an errand? Let's say she asked you to get beans and also asked you to get ground bambara nut. That's opa. For those that are in the East, you might understand what I'm saying. It's powdery. So you were now coming back and somehow you fell. And when you fell, you notice that the beans and the ground powdery bambara nut called opa mixed together. After they mix together, you are now asking yourself, how am I going to explain to my mom that I was coming back and so and so? Anyway, you are in luck today, because with this study, you'll be able to understand that you can use a sieve to separate them from each other. Let's get into what we have for today. We are going to be discussing separation techniques. Join me in this journey. So, separation techniques are those techniques that can be used to separate two different states of matter, such as liquids and solids. Yes. So, once you have different states of matter, not just different states of matter, but it could be the same state of matter and probably different sizes. Once you have that, you need to separate things by physical process. That is separation technique. Separation processes, or a separation method, or simply a separation, is a methodology to attain any mass transfer phenomenon that converts a mixture of substances into two or more distinct products of mixtures. Okay? It is an important asset to purify components of interest from a mixture. Now, why do we need separation techniques? First of all, as I said in my earlier illustration, you mixed your beans and your powdered bambara nut. And what are you supposed to do? Mommy is not going to hear your explanation. So what do you need to do? When you get home, you apply separation techniques. So the first thing is to identify what to be separated from the mixture. So it's important that you are able to know what it's inside a mixture. And one of the needs for separation techniques is identification. The next is to obtain important and pure substances. So when you want to obtain the beans from the powdered bambara nut, yes, you use that. And then finally, to remove something that you do not need.
So let's put up another illustration where you fell and then the beans poured into sand, something like that. So what do you need to do? You are going to apply separation techniques to remove the sand from the beans. Now, what are the types of separation techniques? Separation techniques are simply classified based on the type of mixtures. And the two major classes are solid in liquid and liquid in liquid mixture. Now, for a solid in liquid, you have homogeneous mixture and heterogeneous mixture. The homogeneous mixture can be separated by evaporation to dryness, by distillation, and you also have centrifugation. But on the other hand, also crystallization too. Didn't take note of that. But on the other hand, in a heterogeneous mixture, which is a mixture that are not combined evenly together, you have sedimentation. And after sedimentation, you should apply decantation. You have filtration, you have magnetic separation, you have fractional distillation, and you also have sieving, as we have been mentioning in all of our illustrations. Then let's go to liquid in liquid mixture. In liquid mixture, the homogeneous mixtures can be separated by simple or fractional distillation. It can also be separated by chromatography. Then when you talk about a heterogeneous mixture, it can be separated by your partition separation using your separating funnel. So let's get into them. We'll start with sieving. Sieving is used to separate solid particles of different sizes. It is used in the floor mill or building site. So once you have two different particles and they have different sizes, sieving is the way to go. For instance, when your beans combines with sand, because the sand particle is smaller than the beans, what should you do? You use sieving. In the building site, you can use sieving to separate your pebbles from your sand too, such that you can sieve them, the sand passes through the hole, while the larger particles stay inside the sieve. So as you can see in our illustration, you have that the larger particles are going to stay in the sieve, while the fine particle is going to pass through. And that's that basically. So this is basically all sieving method entails. We go to the next one, magnetic separation. This method involves the separation of magnetic substances from non-magnetic substances by means of a magnet. So once you bring a magnet, you use it. So you will notice all these people in Nigeria, the iron condemn, those guys, when they are going about, they carry their magnets and jump into different areas, water, gutter, inside your kitchen. The point is this, you will notice them with magnets and they're just going around and hovering the magnets in those very dirty areas in the dustbin. What they are simply trying to do is to separate the magnetic substances using magnetic separation. So if there is an iron nail or something like that, it gets attracted to the magnet. So when their eyes can't see it, the magnet attracts it. Now, it takes advantage of the physical property of magnetism. So it is useful only for certain substances, such as your ferromagnetic substances. That is, magnetic substances or materials that are strongly affected by the magnetic field. It also affects your paramagnetic substances, materials that are less affected, but its effect is still noticed. This method involves the separation of magnetic substances from non-magnetic substances by means of magnets. So, if you have that, you have sulfur combined with iron fillings. Because sulfur is non-magnetic and iron is magnetic, it tends to pull the iron out of the sulfur mixture. Application: waste management. So low magnetic field separation in water purification and purification of complex mixture. To remove metal contaminants from pharmaceutical product stream. So when there's a metal inside, it can magnetize it and take it out. Magnetic cell separation. It is currently being used in clinical therapies, more specifically in cancer and hereditary disease researches. These techniques are combined with PCR, which is the polymerase chain reaction, to increase sensitivity and specificity of results. Okay, so that's that basically about separation by magnetism. Decantation. Decantation is a process for the separation of a mixture of immiscible liquids or a liquid and a solid mixture, such as a suspension. Now, the thing about decantation is this: it is basically or majorly used when you are separating your solids that are denser from liquids that are less dense. The principle is this. Now, when it first starts, you have to first sediment the substance before you decant it. You get. So it takes advantage of differences in densities of the liquids. That's one. A separating funnel is an alternative apparatus for separating liquid layers. It has a valve at the bottom to allow draining of the bottom layer. It can give a better separation between the two liquids. Example of this particular separation technique is the mixture of oil and water. So to help us understand this particular application we talked about, that is the separating funnel, you will notice something that in this diagram, kerosene is less dense, water is more dense, it tends to pass through it and then get into a different container. So all this is related to decantation. However, in separating funnel usage, you are particularly talking about a scenario where you have a mixture of immiscible liquids. The other form of decantation is a liquid solid separation. It takes advantage of gravity / sedimentation of solids in the case of solid liquid separation. Now, sedimentation is the tendency of a particle to settle down in the fluid due to certain forces like gravity, centrifugal acceleration, or electromagnetism. All of them basically describe sedimentation. So when you have that the solids go down and settle, if you live in parts of Nigeria where you fetch or use well water, and those well water, when you take them, some of them are usually not so clean. So what do you simply do? You let it settle or add alum, and then after a little while, the dirt will tend to coagulate and then settle at the base of your container. Now, that is sedimentation. So the solid that gets settled down is called the sediment. In the lab, it can be done in test tubes to enhance productivity. Test tubes should be placed at angle 45 degrees to allow the sediments to settle at the bottom of the apparatus. Now, a decanter centrifuge may be used for continuous solid liquid separation. That is in the case of the lab. However, as you can see here, this is the water contaminated with particles, and then now they have all sedimented basically. Now, decantation, you now pour away the lighter or less dense liquid into a different container, leaving the sediments below. So that's that. So the glass rod usually helps to decant properly, as it prevents some particles from flowing in that are not supposed to be there. Okay, with that said, let's move ahead. Decantation's application include: it is frequently used to purify a liquid by separating it from a suspension of insoluble particles. Yes, decantation also present in nanotechnology. It's also used in nanotechnology in the synthesis of high quality silver, nanowire solutions, and fabrication processes of high performance electrodes. Decantation is also being applied, which greatly simplifies the purification process. So basically for purification, decantation is applied. Fat is determined in butter by decantation. So basically, the separation of the denser particle or denser amongst the two of them, fats and butter, basically is what is used to identify its presence. In sugar industry, processing of sugar beets into granular sugar is actually an application of your decantation process in this industry. Okay, we go to the next one, and that is filtration. Thing about filtration is that you use it to separate immiscible. That's when you have a liquid and a heterogeneous liquid solid mixture. Basically, filtration is used. But in this case, the particles are quite smaller than those of decantation. Now, it takes advantage of the physical property of state of matter, its size and solubility. So the fact that the particles are quite small, basically, but not as small enough to pass through a filter paper, that's basically what it takes advantage of. Now, mechanical, physical, or biological operations that separate solids from liquids by adding a medium through which the fluid can pass is called filtration. So if you pass the mixture through a particular, maybe filter paper, through which only the liquid can pass through, that's what you're basically doing, filtration. The substance which is left behind in the filtration medium is called residue, while the liquid which passes through the filtration medium is called a filtrate. Okay, so we have this structure. You will notice that because of the size of the solid particles, they are held back by this filter, hence allowing only the liquids to pass through. So these particles that are held back are the residues, while the particles that pass through the filter paper are referred to as the filtrate. Application. The most important technique used by chemists to purify compounds. So it is the most important technique used by chemists to purify compounds. HEPA filters in air conditions to remove particles from air. So that's that too. In the laboratory, a Buchner funnel is often used with a filter paper serving as a porous barrier. So it's majorly for purification of substances. Okay, we go to the next one, centrifugation. Centrifugation is used to separate a mixture where the solid particles do not settle fast. Yes, so if the solid particles settle fast, decantation is okay. But then in a situation where the solid particles do not settle faster, centrifugation is the way to go. And which are very small in size and can't be separated by filtration. So in a situation where you notice that you can't apply decantation nor filtration, centrifugation is the way. So centrifugation is a technique which involves the application of centrifugal force to separate particles from the solution according to their size, shape, density, viscosity of the medium, and their rotor speed. So basically what happens here is the centrifuge is a device that separates the mixture by spinning so fast. As it's spinning as fast as possible, those particles that need to be separated would move towards the bottom of the test tube or whatever container is introduced to the centrifuge, while the liquid or the less dense medium would now come or be placed above. Now, by doing that, you have actually separated the two components in the mixture. Remember, we said it is used in a situation where the particles do not settle fast or sediment fast, and then when the particles are too small and usually can pass through the filter paper. So when you can't use decantation nor filtration, the way to go is centrifugation. Now, more dense components of the mixture migrate away from the axis of the centrifuge, while less dense components would migrate towards the axis. That is, if you have a test tube, we would see, you will notice that the more dense particles went down, the less dense one are above. So that's that, basically. Okay, so the rate of centrifugation is specified by the angular velocity, usually expressed as revolution per minute, or acceleration expressed as g. The conversion factor between the RPM, which is the revolution per minute, and gravity depends on the radius of the centrifuge rotor. So there's a relationship between that. Now, you just put it in a centrifuge and then it begins to rotate rapidly. As it's rotating, you notice that before they used to be suspended on top, but now, after centrifugation, they are pushed towards the bottom. And after this is happening, you can actually now separate the mixture. Applications of centrifugation. Now, microcentrifuges are used to process small volumes of biological molecules, cells, or nuclei. So in cases where you need to separate some cells, like your blood cells, you can actually use the microcentrifugation. It is used in diagnostic laboratories for blood and urine tests. Yes. It also aids in the separation of protein using purification techniques such as salting out. Differential centrifugation is used to separate organelles and membranes found in the cell. So that's that basically about centrifugation. The next concept we are going to talk about is evaporation to dryness. So you have that it is basically used in a situation or in a condition where you have a homogeneous mixture of a solid and a liquid. Now, it is a type of evaporation that occurs on the surface of a liquid as it changes into gas phase. So, boiling doesn't necessarily occur. It's just that there is like vaporization of the particles or parts of the liquid. That's the surface part of the liquid. This separation technique can be used to separate solutes that dissolve in solvents. Yes, so the emphasis here is that any solid that is separated by evaporation from a liquid solution must be a solid that is not easily destroyed by heat. This is something you should take note of because evaporation involves a lot of exposure to heat. Now, factors affecting evaporation. Concentration of the substance evaporating in the air. Yes, so if you have a lot of moisture in the air, it tends to reduce evaporation. The flow rate of air pressure and temperature. So in a situation where air is moving fast and moving away the evaporated substances, it tends to increase your evaporation. The surface area. Surface area is basically the part that is exposed. So if you put the mixture in a cup or a test tube, the surface area that will be exposed would be small. That's why it is usually put in a dish, a wide dish, as we can see in this diagram, so that it will give it high surface area to be evaporated. Then we have intermolecular forces. That is the forces between the liquids and basically the solid involved. Now, application. It is majorly used to recover salts from solutions, yes. But remember that those salts are salts that are not easily decomposed by heat. The use of evaporation to dryness, concentrate samples basically in the lab during analysis. It is also used for demineralization of water. When you want to remove minerals from water, you use evaporation to dryness. Separating funnel, as we have discussed before, it involves the use of a specialized funnel to separate immiscible liquids of different density. The denser liquid sinks to the bottom and is tapped out first. So as you can see that if you have kerosene and water, kerosene being less dense will be hanging while the water is down. So when you open the tap, you keep removing the water until it is almost completely removed. Then you shut it down and you have kerosene remaining. The next one is distillation. We have come into a situation where we need to separate liquids from liquids. And in distillation, it is used to separate miscible liquids, liquids that combine homogeneously. So, distillation is an effective method to separate mixtures comprised of two or more pure liquids. The separation of mixture of liquids is based on the physical property of boiling point. The other thing to note is that distillation is a purification process where the components of the liquid mixture are vaporized and then condensed and isolated. So you heat, one of them boils away, you now condense them and then you separate them from the mixture. As I said, you use distillation when you have that the liquid mixture is miscible, they are homogeneous. For instance, if I happen to combine water and alcohol, you will notice that that is a homogeneous mixture. But kerosene and water is heterogeneous. And because it is heterogeneous, I am going to be applying my separating funnel. Okay, so we have that basically. So the mixture is heated until one of the components boils away. The vapor is then fed into a condenser which cools the vapor and changes it back to the liquid called a distillate. What remains in the original container is called a residue. Okay, so basically this is the setup for simple distillation. What basically happens is that you heat it, pass it through the big condenser, and then eventually it comes out as a distillate here, while whatever is remaining at this point is referred to as the residue. In the case of your fractional distillation, the only difference is that you need to introduce a fractionating column. That's the major difference. So the presence of a fractionating column is what differentiates your simple distillation from your fractional distillation. Now, the extra thing I would like to say about the difference between simple and fractional is that simple distillation is used to separate liquid mixtures which boil without decomposition. And then they have enough differences in their boiling point. So when the boiling point difference is quite large, use simple distillation. But in a situation where the boiling point is less than 25 Kelvin or 25, the boiling point difference is less than 25 Kelvin or 25 degrees Celsius, the implication is that you are supposed to use fractional distillation. Okay, so let's look at the applications. When you are dealing with your separation of acetone and water, acetone has a boiling point of about 56 degrees Celsius. Water is 100, so you notice that it's more than 25. In the case of alcohol, slightly within the range, you get. So basically those guys can be separated by simple distillation. However, when you have that, the difference in their temperatures is small, is infinitesimal or not so large. The range we are given is less than 25 Kelvin. You basically use your fractional distillation. The extra thing that is noted about fractional distillation is that in fractional distillation, you always introduce your fractionating column. That's the major one other difference that differentiates them. Now, it can be applied, fractional distillation can be applied for the separation of different fractions from petroleum products. It can also be applied for separation of a mixture of methanol and ethanol because their boiling points are quite close to each other. Okay, with that said, let's look at other applications. You can use distillation to separate volatile oils. It can be used for separation of drugs obtained from plants or animal sources, vitamin A from fish liver oil and the rest of them, purification of organic solvents. It can be used in the manufacture of official preparations, spirits of nitrous, ether, spirits of ammonia, distilled water, and water for injection. Now, it can also be used in refining of petroleum products. This is where the big money comes in, at least in Nigeria, and in so many other oil producing countries. We go to the next one, crystallization. Now, crystallization is the natural or artificial process by which a solid forms, where the atoms of the molecules are highly organized into a structure known as crystals. It is used to separate dissolved heat liable. When you say heat liable, it means solids that can decompose on heating. So any solid that you notice that if you heat it or expose it to heat too much, it tends to decompose. You don't apply evaporation to dryness. What you apply instead is crystallization. So most minerals or organic molecules crystallize easily, and the resulting crystals are generally of good quality. That's without visible defects. Now, first, the solution is heated. I'm talking about the procedure now to evaporate most of the solvents to make it hot and nearly saturated. So you don't just start crystallizing straight up. When you remove some of the liquids, it will not break down the substance, it will simply evaporate some of them by heating it. After which, the hot solution is kept for cooling. Now, as you tend to cool or reduce the temperature of a substance, of a solution, the solubility tends to decrease because solubility is directly proportional to temperature. Hence, as the solubility is reducing with the solution cooling, particles begin to crystallize. So just have that in mind, that that is the basic principle behind crystallization. Solubility. So the physical property on which crystallization is dependent on is solubility. Now, the crystals which are formed can be separated from the remaining solution by filtration. Yes, because those crystals are not dissolved in the solution. So, because they are not dissolved, they can actually be separated by filtration. So that's basically that. First heat it to reduce the quantity of the liquid, and because it is hot, you will notice that the solubility is high, but as it begins to cool, it begins to bring out crystals, and those crystals come out of the solution because the solubility tends to reduce as cooling or reduction in temperature occurs. Okay, application. Purification of drugs, separation of crystals of alum from impurities. Then we talk about fractional crystallization. It is possible to separate a mixture of different ionic compounds having identical chemical composition by dissolving them in water and adjusting their temperature of the solution so that one compound crystallizes out and the other doesn't. If you consider potassium sulfate and potassium nitrate, these two salts are soluble, and when you put them inside water, how can I separate a particular mixture of salts that are both soluble? By using fractional crystallization. In this case, you are now going to be considering their differences in crystallization at different temperature. There's a temperature at which K2SO4 will crystallize while KNO3 will remain soluble. So that's basically the principle behind fractional crystallization. Checking out for the temperatures at which one of them crystallizes while the other one remains soluble. And once you apply that, you would have a separation of the mixture. The next one we're going to talk about is sublimation. Sublimation is simply the transition of a substance directly from solid to gas phase without passing through the intermediate liquid phase. Straight up. So if you, for instance, consider your camphor, most of you in Nigeria should know this, or iodine. Basically, these are substances that convert or turn from solid to gas straight up without a liquid phase. That white stuff that we put in our Ghana must go, if you remember, for those of us that grew up back in the day, you understand? So you remember those white stuff that your mommy used to put inside bag that smells somehow. You notice that if you bring it, put inside the bag, before you know it, all of them will turn into gas, and you notice that the size is reducing, but liquid is not being produced. The implication is that it is going straight from solid to gas without an intermediate liquid state, and that process is known as sublimation. Now, this technique takes the advantage of substances that have sublimable properties. Separate a mixture of solids containing one which sublimes and the other which does not sublime by heating. So if you combine something like iodine and sand, iodine can sublime, it will be separated while the sand remains. Okay, so that's basically the setup that describes that. Ammonium chloride is also an example of a substance that sublimes, your camphor and the rest of them. Application. If you want to separate iodine from sand, sublimation is the way. Dye sublimation printer helps in rendering digital pictures in a detailed and realistic fashion, which helps in the analysis of the substance. Sublimation finds practical application in forensic science. Chemists usually prefer sublimation as a purification method to purify volatile compounds. So that's that basically. Then we go to the final type of separation technique, and that is chromatography. Chromatography is a separation technique that is used to separate the different components in a liquid mixture. The mixture is simply dissolved in a fluid called the mobile phase, which carries it through a structure holding another material called the stationary phase. So, if you are talking about chromatography, the first thing is this: It is used to separate components on the basis of their rate of dispersal in the stationary phase. So when you introduce the mobile phase, which will carry the whole component, you will notice that some of the particles in the mixture you want to separate can actually move faster in this stationary phase than the others. So chromatography is a vast separation technique which has many methods or has different principles of separation involved. Now, but the general concept here is this. You have a mixture of these colors. You introduce them into ethanol, which is the mobile phase. Mobile phase is basically that particular part that carries the whole mixture. Now, if you noticed, some of these particles moved faster than the others. You notice that this one is still down here while blue has already gotten there. So that is the whole principle behind chromatography. You introduce a mobile phase to the mixture, and once the mobile phase begins to carry them and push through the stationary phase, you notice that some of them will go faster, some of them will go slower. That difference in the rate of dispersal actually separates them, and that whole principle is known as chromatography. Finally, we'll be considering the different types of chromatography and their application in the real world. Liquid chromatography. Its application in the real world is testing water samples to look for pollution. Now, one thing about chromatography is that in most cases, it is used for identification and not necessarily separation. That is, you don't use in most cases, you don't use chromatography to obtain substances. You use chromatography to identify the presence of substances. So once you're able to separate them, you can identify that this thing is here, basically. And that's why it is used in your pregnancy test. Yes. One major thing that is tested for in the pregnancy test is the human chronic gonadotropins. So once you have that guy present in the urine, it is identified by using your normal pregnancy test kit. Okay, so that's the rapid test for pregnancy test where you just urinate on the stick and basically that. So the whole principle behind that test is chromatography. And as I said, chromatography is not necessarily used to obtain. In most cases, it is used to identify. Okay, so testing water samples to look for pollution. It is used to analyze metal ions and organize substances in solutions. It uses liquids which may incorporate hydrophilic insoluble molecules, basically. In gas chromatography, it is used in detecting bombs in airports, yes. Identifying and quantifying such drugs as alcohol being used in forensic to compare fiber found on a victim. So gas chromatography is used in the forensic in forensics. Used to analyze volatile gases. Yes, you can use it to check for volatile gases. Helium is used to remove or to move the gaseous mixture through a column of absorbent material. Thin layer chromatography is used in detecting pesticides or insecticide residues in food. It is used in the forensics to analyze the dye composition of fibers. Yeah, that too. Uses an absorbent material on flat glass plates. So this is a simple and rapid method to check the purity of organic compounds. So basically that. Then you have your paper chromatography, which is the one that you should actually have access to or be able to do in your secondary school labs. Now, it is used in separating amino acids and anions, RNA, fingerprinting, separating and testing histamines and antibiotics. The most common type of chromatography is basically paper chromatography. The paper is the stationary phase, which is the phase through which the particles are dispersed. And this uses capillary action to pull the solutes through the paper and separate the solution. With this, we have come to the end of separation technique. I presume that by now, you should know the exact method that you are going to use to separate your powdered bambara nut from your beans. Thank you very much.